Hey Algebra 1, and thanks for tuning in. Today we're looking at 6.1 Part 2. This is still properties of exponents, but now we're going to be focusing on the product of powers, quotient of powers, and powers of powers. It is a lot of powers things. We are going to be writing down 13 things in your notes. It does seem like a lot, but it's a lot of easy, just using your rules and properties to answer questions. So let's go ahead and get started. The first thing we're going to talk about is a product of powers. So you need all your numbers to be real numbers, and then m and n in this example for algebra will be integers. To multiply powers with the same base, you can add their exponents. They do have to have the same base. If they're not the same, you can't add your exponents. I would also maybe copy down one or both of these examples here too. So let's go ahead and pause the video so you can write down number 1 and then click play to go on. Number 2 talks about the quotient of powers. Again, you need to let a be a non-zero number, real number, and m and n can be integers, meaning whole numbers that are positive or negative. When you're trying to divide powers with the same base, here it is again, same, you can subtract their exponents. Like 4 to the 6th power over 4 to the 3rd power is equal to 4 to the 6 minus 3, which is equal to 4 to the 3rd. Another way you look at this is if you have 4 to the 6th power on top, here are 6 4s and then 3 4s, and that's basically just canceling out one from the top and one from the bottom, so you're just left with 4 to the 3rd on the top. This takes a little bit more time to do, so that's why we're learning the rule. So let's go ahead and write down the words and pick one or two of the examples to write down. So let's go ahead and pause here, and once you're done, click play to go on to number 3. Number 3 is the last one we'll learn for this section of notes. We have a little bit more to look at the end. But the power of a power, and that basically is when you have a power of a power, which means you've got an exponent with a base, but then you have another exponent on the outside. You're just going to multiply the exponents together. So again, let's go ahead and copy this down right here, and then once you're done, click play to go on. So let's go ahead and pause if you haven't done so already. Alright, so these are all 3 of our powers we just wrote down. The first one is product of powers, the second one is quotient of powers, and the third is power of powers. With this first one in letter A, the product of powers says with the same base we can add the exponents. Since both of them have a 3, we can add the 2 and the 6. That means my answer would be 3 to the 8th power. Because all I did was added 2 plus 6. For letter B, that one, I have the same base. They are dividing. This is your division problem. So that means I can subtract. This is what that would look like. I would essentially be doing negative 4 to the second power minus negative 4 to the 7th power. 2 minus 7 does give me a negative 5. So I have this. Negative 4 to the negative 5th power in parentheses. In the previous video, we talked about how to change negative exponents into positive ones. So I'd actually need to write this as the reciprocal, 1 over negative 4 to the 5th power. And then I can actually go ahead and simplify this expression too. I'm going to go back to letter A and do that as well. But negative 4 to the 5th power is going to give me negative 1024. So my answer would actually be negative 1 over 1024, because I did 4 times 4 times 4 times 4 times 4 and kept the negative since it's an odd number. And then 3 to the 8th power actually can be written as 6,561. So this would actually be the better answer here. Letter C is the power of powers, and that just means if there is an extra exponent on the outside of the parentheses, you can multiply these together. So that's essentially going to give us z to the negative 12th power, because 4 times negative 3 is negative 12. And then again, I want it to be positive, so I'm going to just write it as the reciprocal. That means z to the 12th power would go on the bottom, and a 1 would just stay up at the top, so we have something up there. Okay? So the next few we're going to try on your own. So here's 4, 5, and 6. Let's go ahead and pause the video here, try it, and then once you're done, click play. Alright, so this first one, this is our product of powers. It has the same base, so I can add my exponents. When I add 4 plus negative 6, I get a negative 2. So initially, I get 10 to the negative 2. but I need it as a positive exponent, and then I can simplify it even further after that. So this is actually going to change to 1 over 10 to the second power. And 1 over 10 to the second power, I can do 10 to the second power. That's 10 times 10, and I'm going to get 100. So my answer for number 4 is 1 over 100. For number 5, we are still using product of powers. They have the same base, so and they're being multiplied. So I can go ahead and add my exponents together. 9 plus negative 9 is going to give me 0. So I have x to the 0 power, which is equal to 1. So my answer to number 5 is 1. Over here for number 6, I have negative 5 to the 8th power over negative 5 to the 4th power. This is our quotient of powers, and because they have the same base and are being divided, I'm going to subtract the exponents. So initially I get this, negative 5 to the 4th power, but then I need to go ahead and look at simplifying this too. And I accidentally put a negative here. This negative actually cancels out because you have a negative divided by a negative. Do we see this right here? So actually it would cancel out and just give us 5 to the 4th power. So that would be 5 timesing itself 4 times, which is equal to 625. It is important that you have a calculator through this because that's just going to create a long time for you to do that type of question. Okay. Here are a few more, 7, 8, and 9, and then we'll get into one more deal of our notes. Again, let's go ahead and simplify the expression. If you have any negative exponents, make sure you change them to positive ones. Let's go ahead and pause the video here, and then click play when you're ready to check. Alright, for number 7, we have y to the 6th over y to the 7th. This is my quotient of powers, so I'm going to subtract. 6 minus 7 gives me negative 1. So initially I have y to the negative 1st power, and to write that as a positive exponent, I'm going to write it as 1 over y to the 1st power, but really I can just get rid of this little exponent and write it as 1 over y. Okay. Number 8, that's your power of powers. So I'm just going to multiply my two exponents. Negative 2 times negative 1 is a positive 2. Yay, we have a positive exponent. 6 to the 2nd power is equal to 36. Same thing for number 9. I'm going to multiply my two exponents. 12 times 5 is going to give me 60. So w to the 60th power will be for number 9. The last thing we're going to learn today is these two concepts, power of a product and power of a quotient property. To find the power of a product, find the power of each factor and multiply. So if there's ever an exponent on the outside, like this one right here, this 5 is going to be distributed to the 3 and the 2. And so you would have 3 to the 5th power and 2 to the 5th power. And then you would multiply those answers together and get a really big answer. Or if you have the algebra expression, the m would be distributed to both the a and the b to get a to the m times b to the m. The same thing is going to be true if you have a quotient or a fraction. You're still going to distribute this exponent to everything inside the parentheses. It doesn't matter if it's on the top or the bottom. So 3 over 2 to the 5th power means the 3 gets the 5 and also the 2 gets the 5. We are going to take a few moments here to write this down. So let's go ahead and copy down what's in the purple boxes, and then once you're ready to try it, go ahead and press play so you can see how it's done and try some on your own. Alright, so I'm going to try letter A first, and then you're going to try 11, 12, and 13. So letter A, this one is called the power of a product property, which means this 2 is going to be distributed with everything that's being multiplied inside. Which means the negative 1.5 will get a 2, and the y would get a 2. And I put the 1.5 in parentheses because it's negative. Then I solve it. Negative 1.5 to the 2nd power is equal to 2.25. And then y to the 2nd power is just y to the 2nd. So this would actually be my answer. Okay? So what you're going to try is 11, 12, and 13. Remember, this exponent on the outside gets distributed to every single thing on the inside. So that includes all the individual variables, all the individual constants or coefficients. Okay? So let's go ahead and get started. Try 11 through 13, and then once you're done, click play to check your work. Okay, to start off with 11, this is what I did. I did my distribution of the 3 to the a and the negative 10. So I get a to the 3rd over negative 10 to the 3rd. Okay, once I'm done with that, then I can go ahead and simplify. A to the third is just going to stay a to the third, but negative 10 to the third I can actually write as negative 1,000, because negative 10 times negative 10 times negative 10 is negative 1,000. So negative a to the third over 1,000, or a to the third over negative 1,000, either one. For number 12, we are distributing a 4 to everything inside the parentheses, so I'll have 3 to the fourth times d to the fourth over 2 to the fourth. Okay? 3 to the fourth is going to give me a number, and so is 2 to the fourth, so let's go ahead and simplify that. 3 to the fourth power is 81. D to the fourth just stays d to the fourth. And then 2 to the fourth power is equal to 16. Notice how 81 and 16 are numbers. I cannot simplify them anymore, so this would be my final answer for number 12. 13, it looks like I have some tricky stuff I'm going to have to work through once I distribute, because I'm distributing a negative exponent, and my instructions say simplify each expression and write your answer only with positive exponents. So let's go and distribute first. I have 2 to the negative fifth power times x to the negative fifth power over 3 to the negative fifth power. All of the things need to be moved to their reciprocal because they all have negative exponents. So I'm going to start here. 2 to the negative fifth power, I'm going to move it down to the new bottom, or the new denominator. The same thing with x to the negative fifth power, I'm going to move it down to the bottom and create it positive. And I'm just crossing these off as I move them, so I don't move them more than one time, or so I remember to move them. And then this 3 to the negative fifth power on the bottom, that's going to be moved to the numerator to make it 3 to the positive fifth power. Once again, you can simplify your numbers and just keep your variable the same. 3 to the fifth power is going to give me 243. And then 2 to the fifth power gives me 32. X to the fifth power stays the same. 243 and 32 do not have any other numbers in common, so this right here would be my final answer. Okay, so it's very important that you're distributing things whenever you're supposed to distribute. Make sure you have those 13 things written down. If you need to go back again and look, or make sure you reference your notes whenever you're trying your homework. Thanks so much for tuning in, and we'll catch you next time.